semester. So as you might be able to tell, I'm a little bit sick this morning. Not sick of you guys, though. I'm just so happy that you're here. So I'm wearing a coat. I'm up here. It's a little cold. And I'm going to ask you this question. What, my dear friends, is wrong with this picture? Oh yeah, I cut my hair. I just kind of whack it all off every now and then. No electrons. Well, keep in mind, this isn't a static picture, as you may have noticed. Every now and then you'll see something. Of course, now I'm blocking it because I'm trying to make sure I got everyone in attendance. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're missing Brazil. Oh, King, I don't think he's in class anymore. And McCarty. McCarty, are you here? Did you miss class again? Oh boy, she's in big trouble. All right. So is it true that there are no electrons? Is that true? Keep staring. Stare long and hard. Yeah, I think so. I think jail's a good punishment. Whew, it's cold. So anything else wrong with this picture? There aren't very many electrons. I mean, that's something wrong with the picture. If you have, a whole bunch of protons, like you do, you can see there's protons and neutrons. It looks like a nucleus, right? Ugh. I'll give you a hint. There are a bunch of electrons in this atom. They're just not being shown because they're like way far outside. In fact, you could imagine, remember that if the nucleus is the size of a pea, the electrons are going to be as far away as 300 yards. So you could imagine they might be very far outside of that. Doesn't show shells. Yes, that's good. I like that. No electron shells. Yeah. And the electron that's coming, it's not like going around the nucleus, it's coming out of the nucleus, right? It appears and comes out of the nucleus. In fact, you can see that there's a green neutron, and when it emits that electron, it turns into a proton, right? So it's green, then that electron flies out of it, and it turns into a proton. And you're saying, what? You're saying, what is going on? Right? Well, that's something that happens called radioactive decay. Beta decay. And now we're talking about the nucleus. Oh, I didn't take away that little block is supposed to be taken away, and so you can see that radioactive decay. Because we're going to talk a little bit about radioactivity today as we discuss the exciting case of Alexander Litvinenko. Have you guys done that assignment yet? The one related to Alexander Litvinenko? Some yes, some no, some oui. Well, we're going to follow up and learn a little bit more about that guy, because why not, right? Next week, you're going to have a project. That's all you're going to have for the week. No other assignments, but a project where you're going to become, you're going to become an atom. You're going to write, you're going to describe what it means to live your life as, say, a helium atom, or an oxygen atom, or a polonium atom, or a lead atom, or whatever it might be. And you can do this as creatively as you like, but I just wanted to let you know that's what's going to be coming up. So you can see in the case of this helium atom, you will enjoy that. Oh, good, good. Using this little program called Prezi, you can come up with sort of different things describing, and I didn't fill this all the way out. I just put a couple of things here. You're going to want to include pictures. Oh, excuse me. Who you like to hang out with, maybe, which might be a way of describing bonding, chemical bonding, who you bond with. A day in the life, things that might happen to you, a funny story, whatever it might be, things that you want to include that are going to help you describe your atom, but in sort of a fun way, you see. At least I think it's fun. And you can do it in just a boring PowerPoint. In fact, I even have an outline of that PowerPoint for you, so you can just follow the outline and just put information and pictures in. It'll all be explained. You don't have to listen to what, you know. You can just tune me out for the next minute. But you can also use Prezi to do kind of a more fun one where you kind of describe as though you are the atom, living the atom's life and coming up with stories and ideas that are going to teach people things about the atom, like how many electrons it's going to have or protons or whatever. So you can either follow the template that I already have for you. It just says like, this is helium. It has two protons and it normally has 2 neutrons, but there's a radioactive isotope that might have 1 neutron, and it usually has 2 electrons when it's, you know, chemically balanced, electrostatically balanced. Okay. You can certainly do that. You could even do a video if you wanted to do a video of yourself. You'll see all the information that needs to be included, but I just wanted to show you what that might look like a little bit so you can kind of get ready for thinking about that, because you're not going to have traditional assignments next week. It's just going to be this atoms assignment, and it's going to be worth a substantial portion of your grade, so don't be a slacker. By substantial, I mean something like maybe 10% of your overall grade, maybe, yeah, something like that. Nice. All right. So we're wrapping things up, and we're talking today about neutrons, and we're wrapping up the atom and going to start talking about bonding once we've finished your atom project next week. And I'll skip this part again. Actually, maybe I won't. Sometimes it's good to see what we're doing. Oh, no, I'll skip it. So I know some of you were still a little confused on the Rutherford's atom. I want to make sure I make clear, and I think I did last week, because I think Ernst Rutherford's experiment is important because it helps us to know how you can probe things that are so small you can't see them, but still learn about their structure. Things like the atom. It's important to understand the structure of the atom as well, you know. So, of course, you're all in the density gang. You guys know the density gang sign, mass over volume. And the whole point of Rutherford's experiment was he realized that we couldn't have an atom that was a positively charged mass spread out, but that mass had to be condensed into a small enough area because every now and then an alpha particle wouldn't just pass through, but would actually be deflected by the atom. So that means the atom must look like this, which is why we developed the model of the atom that we have. And then we asked the question, and just to be clear, before I do the face thing, there we go. We'll talk about the betas and the gammas pretty soon. Or actually, you'll sort of talk about it this week in your assignments. That most neutrons could, or most alpha particles could just pass right through, but every now and then one is going to score a direct hit on this nucleus, and that's when it'll get deflected. So still very rarely, but occasionally that can happen because you have a dense enough object in the middle. Instead of being like a plum pudding, it's like a small little diamond or metal bead. And that's going to be able to deflect things then, because it's so much denser. Oh, you mean what about the betas and the gammas in Rutherford's experiment? He didn't use betas and gammas because they're not very massive. Actually gammas aren't massive at all, they're just photons. And betas are just electrons. So they're not very massive, so they It's not like firing a bullet. It's more like firing a grain of sand or some, oh, I don't know, a piece of popcorn or something. It's not, it's not quite as impressive. Well, it's not that he gets how did he get so he could only be firing alpha particles in a particular direction? Well, certain elements decay using alpha decay. So he would have had to use those certain elements that would decay, and then he'd have to point them in a certain direction. But other than that, I don't really know. So if sunlight could reflect off the ground, oh man, it's deep. I don't even know if I can answer that question. What would happen if sunlight? I mean, it does reflect off the ground. I don't know. All right, back to what we're doing here. So we then ask the question: if the atom is structured like this, with all that mass in the middle, and on the outside there's not really mass, it's just sort of this flitting around these little electrons that are moving super fast, then what happens when your fist, when someone punches you in the face, which I'm sure happens to you all. Oh, I hope it doesn't happen to you. If it does, tell me. I want to help. Like this, perhaps. Is the fist actually touching the person's face? Yeah, it looks painful, doesn't it? And we learned, and you're all answering the question right, very good. We learned that it doesn't. Even in a case like this where it seems, well, of course the fist is touching the face because it's getting like all the way up in there and it might even cause it to bleed or something like that. Well, no, it's just getting so close to it with so much force that those electrons are repelling the electrons and smooshing them in. Smushing your face in and smushing your nose and everything else. Before long, your face is deformed. So it looks just like this. If you can look back up at the... imagine these triangles I have here represent the electrostatic force. And as it turns redder, more force is created. So as the fist moves towards the face, like this, it gets redder. There's more electrostatic force, and that's going to push the squishy bits of the face away from the fist even farther. Right? Want to see that again? So the fist is coming. It's causing more electrostatic repulsion because these electrons don't want to be near each other. They're saying, get me away from this electron, it's too close to me. I want to go away from this electron, it's too close to me. And so then your face responds to that by moving over. And then that electrostatic force goes down. So that's what's going on. No touch is happening as we think of it. It's simply things are getting smooshed out of the way. Sound like a robot? You sound like a robot. Don't talk to me like that, you punk kids. Just kidding. Sometimes that happens when connectivity goes down. Oh, good. Yeah, maybe it was bad connectivity for a second. All right, let's get back to business. All right, next up we have the scientific method. Now we're going to investigate Litvinenko, the case of Alexander Litvinenko, and we're going to use it to help us understand better the scientific method. You see, we don't just want you to learn about different science principles of physics or chemistry, but in order to graduate from high school, the state of Oregon wants you to understand how to use the scientific method to learn things about the world around you, to make decisions about the world around you, etc., etc., etc. Could I repeat that my dogs are barking? Could I repeat that my dogs are barking? Yeah, use punctuation, first of all. Second of all, sorry, I can't. I don't even know what part you want me to repeat. So these are the steps in the scientific method. Observation, looking, observing about the world around you. Questioning, not just seeing. What is that? Not just seeing but watching, or not just seeing but looking, being active so that you're asking questions while you're observing. Then You do background research. We're going to go through these steps over and over. You've already seen this a couple times. Where you say, okay, I have this question about the world around me, like, why is it that a fly comes into my bedroom every night and keeps me awake when I'm trying to go to sleep? So you do background research to learn about flies, maybe, and you see, oh, it's because there's a light on and they're attracted to the light or something like that, right? So then you make a hypothesis, and it might be a general one about like why they're attracted to light, but it also might be one that just relates to how can I get out of my bedroom? So you say, oh, if I turn the light on in the bathroom and turn the lights out in my room, then all the flies or the fly is going to be attracted to the bathroom, and then I can close the door, turn the light out real quick, and run into my room, and there won't be any fly. It'll just be dead, squirming around in the sink when I wake up in the morning. But, whatever. You got to pick your battles. Then you got to test your hypothesis, like by doing exactly what I just said, maybe trying that for a couple nights. See if that gets the fly not coming into your room or whatever it might be. And then if you're doing a more intense experiment where you want to have it repeated and you want to see if there's a connection between two variables, then you're going to record data, you're going to analyze data, and you're going to interpret the results. Does that make sense? Are you with me? Scientific method. Good. And you can actually kind of break that down into an even shorter version where you just say, you think, you research, you make a guess about something, and then you test it. That's how and it's an iterative process. You iterate that over and over again to get closer and closer to what might be the truth. Because just because it worked for me in my house to have the light on in the bathroom to keep the fly from coming into my bedroom doesn't mean it's going to work in your house or at certain temperatures or at certain latitudes or in certain planets or in certain, whatever it might be, or with certain flies. It doesn't mean that you've established a general principle. So that's why we continue doing that research over and over again. Sam, what are you doing? Are you distracting people? If you were invisible, would you go blind because of the light that can't... That is so deep. You guys, you're killing me. Exactly, Guinevere. Thank you. All right. Now, to Litvinenko. Spoiler alert, you're going... If you haven't done this assignment yet, you're going to learn a few things. So, you remember this man, Alexander Litvinenko. He checked into the hospital, not really knowing what was going on, but knowing that he felt very sick and he was vomiting, feeling horrible. And they were trying to take care of him and figured, oh, I see. Nice, Sam. You're being totally helpful. So what observations, first of all, would doctors have made regarding Litvinenko's status? What questions should they ask? All right, remember, they don't even know what's in his system. All they know is he's sick, and they can't figure out why. Did you eat sushi? That's a good question. Those are some things you should ask. Like, what have you eaten recently? That's an obvious thing. Like, if you're putting stuff into your body, what is it? Yes, what are his symptoms? When did he start feeling sick? These are great things you want to know. Ask him if he has any idea what might be happening. Yes. All good questions. So you need to observe and ask lots of questions and make lots of observations. Check his heart rate. Check his breathing rate. Do a CT scan or something. See what's in his body. See if everything's, is he... I think he might have been peeing blood, actually, or something like that. So, figure out what's happening there or whatever. Yeah, sorry, I didn't mean to say that. All right, now you're not a doctor anymore. Now you're a detective, and we're moving on to the next step, which is background research. So we've done some observations. We've asked some questions. That's the O and the Q in Samuel's Sam's acronym he had there, which I guess I'll have to think of like a, see if you can think of a sentence that starts with each of those letters. Like, oh, quiet, something, 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 you know. And I'll use that in the future. You're a detective who arrives at the hospital just after doctors determined that Litvinenko is dying from polonium. So now you know it's polonium, but now you're a detective. You're not so worried about healing him. You're more worried about figuring out if there was a crime that was committed. So just because he has polonium in his system, doesn't mean that he was poisoned or anything. It just means you know there's polonium in his system. So what kind of background research do you need to do now that you've discovered that the doctors have told you this guy is dying from polonium, too much polonium in his body? All right, so look into his life, people like motive that might have contacted him. Yeah. All right, you guys are kind of jumping ahead because you know too much. But remember, all we know now is this guy's dying from polonium. We don't necessarily know that there was poisoning or anything else, but we're trying to figure out if there is some sort of foul play. Yeah. Look into money transactions. That's good. Yeah, you definitely would want to do that. Start investigating lots of different avenues, collecting data. But in a sense, we're not doing data on an experiment yet. Right now, we're just doing background research. Okay, when do you start feeling sick? Yeah. Ask him if he's been in contact with polonium. Do you know anything about polonium? Blah, 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 blah. All right, well, here's some of those questions. You actually have to ask, first of all, what is polonium? I bet you that 9 detectives out of 10 don't have any idea what polonium is, so they got to go figure that out, right? You got to find an expert on polonium. What's polonium? Where's it made? How do people get it? That kind of thing. And you might discover if you did some research on that, which they eventually did discover. Luckily, they almost didn't find any of this out and thought it would have been an unexplained death. 90% of the polonium in the world is produced at one nuclear reactor on the Volga River in Russia. Whoa, okay, that's interesting. There's a Russian connection then, okay? It would seem. Then can it be traced? If we can trace where this polonium went, that would be helpful for locating this. Well, because only Russia, I guess, is interested in making polonium. It's not really very useful for very much.
Except perhaps for killing people.
How would someone obtain it? It looks like it would cost, if you were to generate your own polonium, you'd need about $30 million to buy some on the black market or something like that from some research that I did in the black market. Don't tell the feds. So, all right, now we're on our B here from Elizabeth Day. Thank you for background research. So we're learning about polonium. So what is polonium? Here's polonium. You can see it's a very big atom. It has atomic number 84. What does that mean? What does it mean that it has atomic number 84? What does that tell us about polonium? This wasn't even that long ago, actually. This was fairly recently. 84 protons. And, yes, if it's electrically neutral, it'll have 84 electrons as well. Yes, so that's polonium, so a pretty heavy element. And then you can look it up on the periodic table. As a good detective, of course, you're going to flip open your periodic table. You're going to say, hey, look over here. Polonium, 84, all right. I see that. Pretty heavy element. And then you might see, oh, it decays into lead. Right next to it here. PB, funny, I don't know why, but that's the... Oh, 2006. Oh, thank you, yeah. All right, so 10 years ago. I guess it was a while ago. You guys were just tiny little pipsqueaks back then, weren't you? Not really sure what a pipsqueak is. So yeah, polonium decays into lead. So then you might look up some, images online and see, okay, so here's what polonium looks like, and then it decays into lead through alpha decay, so it releases alpha particle. Aha! So it's those alpha particles going throughout your body that must be doing the damage. As that polonium decays into lead, it's going to emit those alpha particles into your body, and they're going to shoot, and they're going to be all in your tissues wherever the polonium went. et cetera, et cetera. So there's some of your research. Good. Now you're going to do some more research on the people themselves. So Litvinenko would have told you that he had lunch with Mario Scaramella, and he had dinner with Andrei Lugovoy. And Litvinenko sort of implies to you that Scaramella might be the assassin. But, it's not really saying for sure. Oh, good. I taught your brother how to steal cars. Okay, good. So let's go find Scaramella and Lugovoy and interview them. That's a good idea. Trouble is, Lugovoy has already gone back to Russia. Litvinenko implies, though, that Scaramella is the assassin. You see, and then he tells you that Scaramella and he had discussed KGB connections, that's the secret police in Russia, to Italian politicians, and Scaramella had given him alleged evidence about the killing of another person, Anna Politkovskaya, 3 weeks earlier, and a copy of a Russian Secret Service hit list. Apparently, Scaramella showed him this hit list, on which both Scaramella and Litvinenko were targets. And Anna Politkovskaya, who was shot by hitmen in her apartment. So, it would seem like they talked about stuff that would make them both look like the Russian state was out to get both of them. So why would Scaramella be wanting to kill him? So now that you've done some research, we have to form a hypothesis. So this is the core, the fundamental basis of science, is forming a hypothesis. So I want you to say, first of all, who do you think is responsible, Scaramella or Lugovoy? All right, yeah, Scaramella is the one on the left. All right, so it's evenly split. Because he indicated it was Scaramella, but then you also think, well, but Scaramella and he are both on this hit list. So who knows? All right, so you think your person is responsible. Then I want you to say why. Why do you think that person is responsible? And it could be something at this point as simple as he looks like a mean guy, if you want to say that. But you can also say if you have some other information that you've picked up or remember from what I've said already. All right, so we know that Lugovoy left the country. So that's maybe he's fleeing the scene of the crime. It's good. Ah, Scaramella looks nice, but evil on the inside. Diabolical. Not smiling. The guy on the right, though, is smiling. Oh, by the way, the guy in the middle here is just Litvinenko. Oh, I see. Polonium acts quickly, and Lugovoy was the last to see him. All right. Well, it turns out, in our hypothesis, we want to create something that would show who did it. So one thing you might say is if there's a polonium trail, right, with one of these guys, then that's going to be the one that's responsible, right? If we can find a polonium trail where one of these guys went, right? So that might be a hypothesis that you could then test. So if the places where Lugovoy went has lots of traces of polonium, then he's responsible. If the place where Scaramella went, then he's responsible. You might also do some research and find out, oh, Litvinenko wrote this book called Blowing Up Russia, where he accused of Vladimir Putin of actually blowing up an apartment building so he could blame it on the Chechens, so he could basically start a war with Chechnya. And if that's the case, or if he did that, then obviously Putin is going to be someone who's in. We'll get to Putin in a little while. It's going to be someone who's going to want Litvinenko dead, right? And Lugovoy is someone who works for Vladimir Putin. Oh, I don't know. Putin's probably 74 or something like that. Right, that's not an idea. Sorry, anyway. So anyway, now we have to test our hypothesis. right? So now we're going to go through the streets of London. Or perhaps we're going to interview Scaramella or Lugavoy, or go to the places where they went, etc., etc. Or talk to witnesses. Norberto Andrade, who was a waiter at the place where Lugavoy had tea, right here. I forget what it's called. It's in my notes. Can everyone else hear me? Okay. So I'm only frozen for Elizabeth. And every time we say frozen, we have to sing, right? What's another song from that movie? I can't. I don't want to sing the Let It Go song all the time. Isn't there another good song in there? Oh, from the movie Frozen. I'm sorry. This is Norberto Andrade. No reason to sing. All right, sounds good. Norberto Andrade has quite a few interesting things to say. He says, because he actually served the tea to these people, he says that he remembers a lot of times where he felt like he was being distracted from the tea. Like they were like, go over there, or something like that, and trying to get him out of the picture while he was serving the tea. He also remembers that after when he took the tea back and dumped it back out, that it was yellow and kind of thicker than it usually is. Those are a couple things he remembers, which is like, that's interesting. And then you might say, well, does polonium make things thicker, if you put it in liquid? I'm talking about the place where Lugavoy had tea with Litvinenko shortly before he was hospitalized. Norberto Andrade was their waiter. You might check for trails, and you might find, as they did in this restaurant, that there was polonium splashed all over the table where they were sitting, the picture up against the table, the pine bar. That's right. Thank you. And then they found more polonium trails as they found the airplane that Lugavoy took back to Russia because he was carrying this polonium with him. The seat that he sat in when he went to a soccer match, which was actually had so much polonium in it, or poisoning near it, that was sort of some residual polonium from whatever he was carrying it in, that they had to burn the seat. They couldn't use it anymore. So this really puts the finger on Lugavoy, and you can find these faint trails of polonium, if you look for them, all around where Lugavoy went. And the interesting thing is that the reason, we found this out later, that Litvinenko indicated it might be Scaramella was because he wanted Lugavoy to feel safe to stay in London. Because, of course, once Lugavoy goes back to Russia, he has the protection of the Russian state. They're not going to give him back to London. So Litvinenko was trying to make them feel safe, like, oh, they're just going to investigate this Scaramella guy. He's probably, because that's who, Litvinenko thinks actually did it. So that's why you have to be careful. There's sometimes tricky or evidence you don't expect. So now we're going to collect and analyze our data. We're just going to put it all together here. Polonium trails were found. Litvinenko's was not as pronounced as the trail left by Lugavoy, but the reason for that is because Litvinenko had the polonium in his body, and it only really is going to come out in your sweat. But Lugavoy had a much more pronounced trail because he must have had the container with the polonium in it. Scaramella also tested positive for a small amount of polonium, but we all have, I think, a little bit actually of polonium in us, which is, I suppose, kind of frightening. The Russian media, here's some more data, announced that Lugavoy tested negative for a lie detector test. So he said, oh, I didn't do it. So I guess that's another piece of evidence we can take into account. But most people obviously don't buy the results of those lie detector tests. And so now we have to interpret the results. We've learned about this particular case. We're almost positive that Lugavoy carried out this attack on purpose in the Pine Bar and poisoned Litvinenko. But we want to draw some broader inferences. We want to make sure this doesn't happen in the future. Now that we know, we didn't even know polonium was ever used as a poison, and we almost didn't catch it here. And if we wouldn't have caught it, we wouldn't have known to even look for it. So what kinds of things should we learn from this event? We now have to take the results of our experiment, and this is what you always do in science, and think about new questions to ask, new experiments to do, new things we need to investigate or could investigate. So, what about in this case? What should we learn? What further research should we do? And I'm not just talking about scientific research about polonium, but I'm talking about how to avoid these kind of attacks in the future, or that kind of thing. Don't drink tea, says Joel, especially, I suppose, if it's thick and yellow, or becomes thick and yellow. Would Litvinenko make the person... Did I not record this class again? Did I forget? I forgot again, didn't I? Totally blew it. Oh, no, I didn't. I'm recording it. Ha ha! I'm brilliant. I love myself. I never make mistakes. Make sure that people can't carry polonium. That's a great one. We want to make sure that polonium is not accessible to people, and that we can maybe test for it. When you come into an airport and you're carrying a vial of polonium, might be something we'd like to know if you're coming to the New York airport or something like that. All right. Those are some good things. I think there's some others, though. And another question we should ask ourselves. Well, let me actually, before I do that, some other things we should learn from this event are, what are the connections to the greater Russian? Why are they trying to kill Litvinenko? Is Putin actually behind this himself, or did Lugavoy somehow do this on his own? Should we trust, Vladimir Putin? Might be another question. We should find out more about where polonium is being produced and how to get it on the black market. Yeah, those are great things to figure out. Maybe find out if other people have been poisoned under mysterious circumstances and nobody knew what was happening to them. But if we go back and maybe check their bodies, we might find, oh, there's a bunch of polonium in their bodies, right? Maybe they were poisoned that way too. In fact, they think, some people think that Yasser Arafat was poisoned, I think, with polonium, and killed that way. Oh yeah, where's that last 10% produced? That's a good one, Harrison. We'd like to know that so we can keep track of where all of it is in the world, at least all that we know about. Yeah. All right, and then another thing we do when we're interpreting results is we want to be careful to say we haven't proven anything. We've got evidence, maybe enough to stand up in the court of law. Almost certainly it is enough. But it doesn't necessarily prove it. It doesn't prove that Putin's behind it. It doesn't even prove that Lugavoy did it or did it on purpose. He might have thought that maybe someone gave him this little bit of rose water, and he thought, oh, I'll put some rose water in the polonium. Or maybe he was held at gunpoint, or maybe someone put a mind-controlling thing in his mind to make him do what he wanted, or maybe it was a robot of Lugavoy, and it wasn't really Lugavoy himself that came over. So we have to make sure that we're always considering or skeptical about the research that we find to help us arrive at, to help us to continue to research, I guess. Yeah, where do they get stuff to make polonium? Or was it me? No. What other explanations might there be for this? And I've just, gave you a couple of them. Maybe Litvinenko killed himself, and he wanted to, because he was like, I just want to die, I hate life. Or maybe he knew he was going to die of something else, and he said, but I'm going to die and frame this Lugavoy guy, or I want to make Vladimir Putin look bad because obviously he didn't like Vladimir Putin. So I'm going to die and make it look like Vladimir Putin did it to me. So I just had tea with these guys, but I'm just going to drink some polonium and stick this in Lugovoy's pocket so it looks like he did it. Whatever, it could be anything like that. So we do have to be careful when we're interpreting our results. But it does look like, and I'm certainly convinced that this guy, Putin, that's Putin, the first picture here, who has been protecting Lugovoy ever since this event from ever being extradited to another country or anything else, and has taken good care of him. Not Scaramella, who seems to be another person that they're trying to actually kill, and not Norberto Andrade, uh, committed this crime, although it could have been any of these guys, as I've already said, or somebody else. Other evidence, though, is that other people that oppose Vladimir Putin have also experienced frightening deaths. I already mentioned Anna Politkovskaya, who was killed by hitmen in her apartment, and there was no one was ever arrested for ordering the hit. The hitmen were arrested, but no one was ever arrested for ordering the hit. Gerbid Gorbuntsov, who was almost killed, but not quite. Alexander Pilchiny, who was found collapsed after jogging, but seemed to perhaps have been poisoned by this other strange flower called geranium or something like that. All of these people were critical. Politskaya was a journalist critical of Vladimir Putin. Boris Berezovsky was a rich tycoon found hanged in his own bathroom, but perhaps he was hanged by someone else. He never, and no one ever thought he was the kind of person who was depressed in any way. And this guy Magnitsky, who wrote an article critical of Vladimir Putin, actually wrote a book and did a lot of research, supported by Gorbuntsov, as a matter of fact. And he was kept in a Russian prison for less than a year, just less than a year, because you can't keep a prisoner for more than a year in Russia without giving them grounds for why they are being imprisoned. But he was kept there for almost a year and died mysteriously in prison right before the year was up. Sorry. But you can see that there seems to be this pattern that people that oppose Vladimir Putin, especially publicly, especially in ways that could humiliate him or cause him political damage, seem to wind up dead. And Litvinenko, in fact, spoke directly to Putin on his deathbed, saying, as he was dying in that hospital in London, "You may succeed in silencing me, but that silence comes at a price. You've shown yourself to be as barbaric and ruthless as your most hostile critics have claimed. You have shown yourself to have no respect for life, liberty, or any civilized value." Oh, you can't see that? What? "You've shown yourself to be unworthy of your office, to be unworthy of the trust of civilized men and women. You may succeed in silencing one man, but the howl of protest from around the world will reverberate, Mr. Putin, in your ears for the rest of your life. May God forgive you for what you have done, not only to me, but to beloved Russia and its people." That is the end of the story of Alexander Litvinenko. Thank you for coming to class today. I hope that you learned about the scientific method through that. I hope that was helpful for you to see how we use the scientific method, not just in science, but in many ways in life, whether it's getting flies out of our bedroom or protecting ourselves from polonium poisoning. Oh, quaint Brian, have the right artificial intelligence. I like it very much. Thank you. Or oh, quaint brain, I suppose. It's nice. All right, you guys have a good week. Please stay on top of your work as you've been doing, and I'll try to stay on top of grading it. I'll see you guys next week. If you have questions as you're starting your project, feel free to let me know, but do read carefully what I've written out for you next week with that project, because I think all your questions should be answered. Oh, I didn't show you Magnitsky's. Adios, amigos.